All right, let's continue on with example 4 that we were talking about in the last video, and show how we can find percentiles for values that don't fall onto an even number of standard deviations. When we have a specific integer value for the z-score, we know we're a specific integer away in terms of standard deviations, then we can use our empirical rule. But when it's not an exact number of standard deviations away, we have to use calculators to help us out here. So we're going to do that in this example. It says what percent of the weights are between 155 and 165. We saw again the mean was 160. And we're interested in the percentage of weights that are between 155 and 165. Now this might look like I've put them a standard deviation away, but this not to scale. It's not actually a whole standard deviation away, because we saw the standard deviation is equal to 13. So a standard deviation would actually be farther out here, but just for the sake of illustration, we're trying to find the percentage of weights that are between these scores. This is the percent that we're looking for. Again, it's not equal to a specific number of standard deviations away, so we're going to use our calculator, and we're going to use what's called the normal CDF function. Okay, the idea of the normal CDF function is it tells you specifically the percentage of scores that fall between two particular values for any normal distribution. Okay, CDF stands for cumulative distribution function. It's the accumulated amount of data that falls within two particular endpoints. Okay, so depending on your calculator, this can be pretty straightforward and easy to operate here. But when you do the normal CDF function, you're going to need to know a few things. You're going to want to know what the lower bound is. You also need to know what your upper bound is. And you also need to know what your average is, as well as your standard deviation. Okay, those are the four things you'll need to know to use your normal CDF command. So in this particular problem, we're going to want to type in normal CDF. We're going to put in our lower bound is 155. That's the lower bound of the scores we're interested in. Our upper bound is 165. The average for our data set is 160. And the standard deviation for our data set we found earlier to be 13. So this is what we need to enter into our calculator. I'm going to show you a couple of options for how you can calculate this. If you have the Inspire, the directions are in our notes on the next page on how to do it in the TI Inspire. I'll show you real fast in that. So we'll get our answer, and then I'll show you a more practical option probably for most of you who don't have the Inspire. But it's just going to be in the menu under Stats, Distributions. We're looking at a particular type of distribution, specifically the normal. And here's the normal CDF. And then now it asks for the four things that I mentioned. Right? We need to know the lower bound was 155. The upper bound was 165. Mu, this is another Greek letter mu here. I'll talk about that a little bit more in a minute. But that's just another letter for average, specifically for the population average. I haven't taken the time to distinguish between those here, but when you see mu, that means average. Sigma there is standard deviation, which we know is 13. And we see 0.299 is our proportion. That's our percentage, 29.9%. So this value is 0.299. So 29.9% of weights will be between 155 and 165, about 29.9%, right? Okay, so there's using the normal CDF. Another option that's going to be probably better for most of you, since I doubt most of you have that Inspire calculator. If you have the 83 or the 84 or the 89, the TI calculators, any of those can do this as well. It's a similar series of commands, but you might want to Google how to do it on your particular calculator. Another option is if you don't have a graphing calculator, all these types of calculators are available on the internet, so you could just do normal CDF. You could Google normal CDF calculator, and there's going to be a bunch of great ones popping up. The online stat book. This is a great resource for all the different types of calculators you might need in statistics. So Google the particular calculator that you need. We need the normal CDF. And again, it's asking us for the same basic things here that we want to know. It's a little bit different in how it specifies things, but we want the mean, we know is 160. The standard deviation, we know is 13. And now what's a little bit weird is we can either find the percentage of scores that are above a particular value, or the percentage of scores that are below a particular value, or between two values or outside of two values. We're doing between two values, right? We want to know what percentage of scores are between 155 and 165. So we want to do between 155 and 165. And there we go. There's a nice visual. Again, this is a little more to scale than the way I drew it, right? They marked it out at 1 standard deviation, 2 standard deviations. But that's the same basic diagram that I drew. And it gives us our percentage of scores that are between it at 29.95%. They rounded to 4 decimal places. I rounded a different spot, but it's essentially the same, right? 2.299. If we had rounded here to the 4th decimal, we would have gotten 5. So same value from their calculator. So you can use the online stat book for any of the calculator needs that we need in this chapter. Just Google normal CDF calculator and it'll pull it up, or go to onlinestatbook.com. And there's how we can determine the percentage of scores that are between two values using the calculator. So let's go ahead and do a couple more examples to round out the section here. So it says use the calculator to determine the percentile rank for a height of 150 for a 10-year-old child. Okay, so let's remember here. It'd be easy to get our data sets crossed up here, but the 10-year-old children, if we go way back to the beginning here, we saw that the average height of a 10-year-old child was 138, and the standard deviation was 5. Okay. All right, we saw that here as well. Mean is 138, standard deviation is 5. Just to talk quickly again about this mu letter. This is the Greek letter mu. It looks like a U with an extra tail hanging a little lower on the left side. It's called mu. That's a long U. Mu. Okay. This means population average. So if we know the true average for the whole population, we'll call it mu. If we only know it for a sample, we'll call it x bar. If you're getting them a little bit twisted up for now, that's fine, but just know that mu means average, just like x bar. All right, so anyhow, it says use the calculator to determine the percentile rank for the height of 150 for 10-year-old children. We know that the average was 138, and the standard deviation is 5. So we can draw our bell curve real quick and say, all right, 138 is in the middle. They want to know the percentile rank for 150. So 150 is a couple standard deviations, a little more than a couple standard deviations above. And we want to know what's the percentile rank. Well, that's the percentage of scores that are below 150. So this is again going to be the normal CDF command. And we need to know lower bound, upper bound, average, and standard deviation. The lower bound, well, it's whatever the lowest possible height is. In theory, nobody's going to be 0 centimeters tall, but we can use that as a good lower bound since nobody's going to be below 0 centimeters tall. And the upper bound is the value that we're looking at. We want to know what percentage of scores fall below 150. And the average, we said, is 138. And the standard deviation is 5, so we can just type normal CDF and all these values into our calculator. I'll use the online one. We know that the average, again, was 138. And the standard deviation was 5. We want to know what percentage of scores are below 150. And we get 0.9918. So 99.2%. 0.9918. 99.2% of children will be below 150 centimeters. We'll do one more example. Determine the percentage of students who will earn at least a 90 on a standardized test with an average of 80 and a standard deviation of 70. So same basic procedures. We know that the average is 80 and the standard deviation is 7.3. We can draw our bell curve to see what we're looking for. Oh, that's a pretty ugly one. And we want to know who's going to get at least a 90. So 80 is in the middle. 90 is well above it. And we want to know what percentage are going to score at least 90. So who's going to get higher than a 90? And again, this is our normal CDF command. Our lowest score is 90. Our higher score, so our lower bound. Our upper bound, well, we'll assume it's a 100-point test. And we know that the mean is 80 and the standard deviation is 7.3. So now we can go to our normal CDF calculator. We said the mean was 80, standard deviation was 7.3. We want to know what percentage are going to get above a 90. And we see 0.0854 is our proportion. So we'd expect about 8.5% of students will get above a 90, or I should say get at least a 90 the way they asked it. Students will get at least a 90. Okay, so there's using the normal CDF command, a little bit of some understanding about z-scores and how we can use the normal curve to figure out percentile ranks and the likelihood of getting certain scores and so on. You're going to get a lot of practice there with that in the homework tonight on page 632, and that is the normal distribution.